Yo, it's 4 a.m. William. I just want to apologize because there's no subtitles, but it's 4 a.m. I want to go climbing tomorrow. I swear the next video I will put some subtitles. I will make it shorter, not that many theory. And I hope you enjoy it as much as you can. And good night. Bye bye. Woo! Bon dia. So today I wanted to talk about my final project. It's about oh increíble.
Hey,
Good
hey.
morning. How are you?
Good
Oh,
morning.
good. Yeah,
Yeah,
please
good.
take a seat.
Can I
Yeah, here it's
here?
okay. It's okay.
Okay, okay. Thank you, thank you, thank you. Then.
So
Thank you.
yeah, as I was
Yes,
saying,
yes.
today I wanted to talk about my final project, and it's about
hmm
robotics and AI. And
Oh, but
oh yeah, yeah, you can ask whatever you want. It's so good to see
oh,
you today. I
you
didn't
too,
know
you
you
too,
were
man.
coming. Okay.
yeah. So,
Okay, yeah, that's
what is
great.
AI exactly? Yeah, what
So
is
yeah,
AI exactly?
what's AI?
hmm
What's AI like?
Yeah.
So AI it's just the way we make computers understand and learn from data and then take actions according to this data or taking actions according to what the computer just learned. Inside of AI there's so many branches. I'm going to be using reinforcement learning. It's one of the main three branches of AI.
Oh, but
And yeah, please go on.
yeah, sorry. Yeah, but why reinforcement learning and not
So
another type of AI?
So why reinforcement learning? Reinforcement learning allows us to endow a robot or give the ability to a robot to learn, adapt, and improve in a new environment, like the world that it's around him. The basis of reinforcement learning, you can explain that with the Frozen Lake game. It's this game over here, and there's six main concepts that mainly all reinforcement learning algorithms are using. And the first one, the most important one actually, it's the agent. The agent is the guy who's gonna learn about the environment, the guy who's gonna want to reach a goal or reach some place, the guy who's learning about the environment and the world around him. After that we have the states is just in which position this agent, this little guy over here, is on the map, like the location of this guy, or maybe position or the velocity, acceleration, if he's saying something. After that, we have the actions. The actions are what the agent can do in a certain state. When the agent is in a certain position, he can go to multiple places. So that's the range of actions that the agent can do. For example, in the frozen lake, this guy over here, for example, now it's in the cell 1-1. And from this cell, he can only go either right or down. He only have a range of two options. But if he moves to 2, he can go up, down, left, and right. So he have 4 options. So the actions are the things that the agent can do in a certain state. And how will the agent decide which actions to take in a certain moment? For that, we're going to use a thing called reward system. And the reward system is just a way to give the agent a value or a number or a scalar value, however you want to call it. So the agent knows how closer to the goal the action he just took is taking him. If the action he just took is taking him closer to the goal, the reward will be higher. If the action he just took is taking him far away from the goal, the reward will be lower or even will be a punishment. And a punishment is just a negative reward, right? So who's deciding the reward system? Who's deciding if you get closer, you get certain amount of reward, if you get farther away, you get certain amount of punishment? Who's deciding all this? There's many types of algorithms, and every one of them is treating this issue in a different way, but mainly the one who's deciding the reward system is the policy. And the policy, it's just a set of rules or decision making rules that the agent will follow or will try to follow in order to have the maximum reward from his actions. And those are the main 6 concepts for understanding reinforcement learning algorithms.
But
And so now what I wanted to say is that, oh yeah,
yeah,
please
yeah.
ask.
What are the
Yeah,
main
I'm so
applications?
happy to see you.
Oh, you too.
Hmm.
What are the main applications for? Like, can you use it for? Right?
We have 2 main types of reinforcement learning algorithms, but generally we will talk about 2 of them. One of them is model-free reinforcement learning, the other one is model-based reinforcement learning. What's the difference between of them? Model-free reinforcement learning, the agent doesn't know what's going to happen if he takes an action. So if he wants to know how much reward he's going to get for taking an action, so he actually has to experience the world around him to know how much reward is he getting for every action he's taking. And we can relate this kind of learning with humans, because humans, we learn by trial and error. We try something, we get a reward. Sometimes it's like we make a new friend, sometimes pass an exam, or sometimes we try something, we get hurt, someone yells at us. We can perceive that as a punishment, we can perceive something as a reward. And by taking rewards and punishments, we can go through life, or we can get through our goals. So model-based algorithms, in the other hand, is when the agent has a notion about the world around him. He already knows some things about the world, like how much reward he's gonna get when he's doing certain actions, where the punishments are, where is he gonna find some trouble. This is like if you go to a new country, you already know there's gonna be maybe roads or people or supermarkets, and there will be nature and animals and things that you already have a model in your head about that. So you already know a little bit how to move in the new country, but there's also many things that you don't know how it's gonna work, because it's a completely new place. So if you have to explore the world in order to learn about it, we will be talking about model-free reinforcement learning algorithms. If you already have a notion of the world and you will be trying to maximize the reward you're getting because you already are familiar with it, we will be talking about model-based reinforcement learning algorithms.
And yeah,
And
like what can you use?
oh, the main
Yeah,
application.
like applications.
So the main
yes.
applications are related to the agent. The agent that is the one who's learning, the one who's exploring this new world, can be almost whatever you want. In video games, it's mainly used to make the computer learn how to play video games. It can be like the playing character, it can be an NPC, it can be whatever you want. But in robotics, it's also widely used. In healthcare, like if you want to train a bot to learn from a certain disease or try to treat a health issue. In marketing, you may want to know what's the best advertising that you can give in your website. Also in finance, you can train your bot to learn about marketplace, or you can train your bot to trading cryptocurrencies. So you can use this for so many things. Okay, so to show in a more visual way how reinforcement learning is working, how can we apply it in a very simple example? Not very simple, but you understand. Here we have a program that I found on internet, and I played around with it a little bit, and I changed some things. The programming things now are not important. If some of you like want to discuss or want to teach me something or discuss about anything about the program, because I'm a beginner on this, so if anyone can teach me something, everything is welcomed. As I said, we said there was an agent, there was an environment, and this agent had a set of actions and a set of states, and all of these were governed or were guided by a reward system and a policy. With the reward system and policy and how we perform the actions, how we choose the actions, now we will not get into that right now because I just want to make a general explanation. But once I start going in depth into every algorithm, I will explain the code and all the details on it. Here we just have a graph. A graph is just like a set of points connected between them. And as you see here, we have like 12 points, and all of them are connected between them. And okay, so the goal here will be to create an agent, and the agent will be in a set of states, and the state is just in which number he's in. Like if he's in number 0, he will be in state 0, we will say. And from this state, he will be able to take a set of actions. If he's in 0, he can only go to the number 6. If he's in 6, he can go to 5, 1, 7, and 10, and so on. And 0 as well, of course. The main goal will be to make the agent to learn and to perform the most efficient path from the beginning to the end. The beginning and the end, we can choose it ourselves, but in this case, we will tell, okay, so the 0 is the beginning, 11 is the end. And here we say, okay, the goal is the end. We just run all of these. That's right now, it's not really important. And okay, some things not important. This is the training loop. Here, what we will be doing is training the bot to learn how to move in the environment, and the environment right now is just this graph. So by saying here 1000, what we're doing is, okay, you move in that environment for this set of time and learn from it. If here we put like 100, he he will be learning from the environment less time. If we put 100,000, he will be learning even more time. It depends on the application, it depends on what we want to do, but for a graph of 11 values, I think 1000 is plenty enough. If we run this and we run this is the current state. It means where do we want to start, and we will say, okay, so we start from 0, and we will say when you reach the goal and the goal is 11, stop, because you already reached the goal. So okay, we run this. So what we will see here is the bot saying us which is the more efficient path to take, and the more efficient path will be the one that takes less steps to accomplish, and in this case will be from 0 to 11, so you have to go 0, 6, 7, 11. Here we can see how many iterations, how much time did it take for the bot to reach this conclusion. This is the reward. As we said, he will try different things. He will say, okay, this is getting more rewards, less reward. When he found something that is really rewarding him, he will keep going in that way, keep going in that direction until the reward doesn't increase more, and the loop finally breaks. But now we increased a little bit the graph. Now there's 26 nodes instead of 11, and we will try to see if there's any difference, if it takes more time to reach the same efficient path. So now the goal is 23, but we can change this. We can say, okay, let's try 26 because he's so alone, and we want to see how much time or what's the more efficient path. For example, from 24 to 26. We can start wherever we want. This we will for the moment we will just leave it the same amount of iterations. Okay, 24 to 26. I think that's okay. When it reaches 26, the bot will be accomplished its goal, and that's it, right? So let's see. It's saying the most efficient path is 24, 0, 6, 15, 26. If we remember the last plot, it reached the final decision much faster. So right now, if we increase the number of iterations that it has to take, now we multiply by 10. If we test that again, it should reach that in a much faster way. Oh, we can see here that it tried something, it was going in a good direction, but suddenly, oh man, gone wrong. Not that wrong, because if we see the scale here, it's not much difference. But you can see that after like 1600, it reaches the same path. If we go here, we can say like 24, 0, 6, 15, 26. If there's another path that it takes the same amount of steps, it will choose one randomly, because in this case, the reward system will give the same amount of value for both paths. Okay, but why stop here? So what we did right now is we built a function that it allows us to add more random edges to our graph, more nodes, more edges, more numbers, and interconnect them in a random way. Since we have this function, we can add as much nodes as we want, but because I don't want my computer to die, I need him, I don't have money to buy a new one, I will be adding for the moment like 3500 additional edges. Okay, this is all the edges that it just built, all of these, and this beautiful thing here is our final graph. Okay, so now, because for example I like the number 159 and I like 254, so 254 will be our goal. 159 will be our initial step, and in this case, because I already tried this before, and I think 40,000 like iterations will be a good a good amount of times for the algorithm to learn. This takes some time, but let's go for it. It's taking some time. Oh, that's what I was thinking. I was like, how can two bananas be inside of the same peel? Whoa! I know there's some people that likes to watch the openings. What's this?
Yo. Okay, today estamos aquí.
Out, no more of these boys.
Morty.
More of these boys.
Pim. Yes! Woo! Nice. Okay, so now that it finished, let's run and see how it works. And it says like, okay, the most efficient path is 100 blah 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 blah. even with 40,000 iterations, it couldn't reach like a steady path. It could still learn more things until there's like an optimal point where it says like, okay, this is it. And if you wanna find any more, maybe it will be like the same amount of steps, or there's nothing you can find. Like, this is the most efficient. It already took 5 minutes. It's not a lot, like it's not a lot, but it's like the video's getting too long already. Oh fuck.
Woo! 谢谢 for listening，谢谢，可以。